Good evening, everyone. I'm Mateo Burillo. I work at Sysdig. And this talk is about, obviously, Kubernetes schedulers. Okay. We are going to start with the index for this talk. First, I'm going to talk a little bit about the default Kubernetes scheduler, which has a lot of features. Maybe you don't know about some of these alpha or beta features. And yeah, if you can use the default Kubernetes scheduler, don't go and reinvent the wheel, okay? Use the default one. Then we are going to look at creating your own scheduler. Okay, I have some code, I have some examples. I'm going to do a live demo after that using a cloud cluster, so hopefully everything goes well. And yeah, I'm going to show you a little bit the main loop or the main functions that you will need to implement if you want to create your own. Okay. This first implementation is going to be very naive, very basic, but at the end of the presentation, I have some improvements that you will need to implement to move towards a more production-ready implementation. Okay. Some of them are actually implemented in this code. Some of them are proposed. Some of them will come from the public at the end of the talk. Okay. So we will end with the question and answer, and yeah, looking forward to hear your ideas. So yeah, okay. This talk is not about Sysdig, but allow me 30 seconds. So. Sysdig is the container intelligence platform. If you are using Kubernetes, if you are using microservices, it's just one unified platform that will do monitoring, alerting, runtime security, troubleshooting, forensics. Okay, we have open source versions, we have the commercial versions. Try this at home. Okay, that's all I'm going to say about Sysdig. That's it. Okay, you know that the Kubernetes terminology and concepts are growing every week, every month. It's crazy. So what this talk is also not about. It's not about the Kubernetes horizontal pod autoscaler or HPA. Actually, the HPA is a little more difficult to implement. I have another running implementation if you go to that URL. Okay, so I suppose everyone knows how to run an HPA and what an HPA does, scales the number of pods in a deployment. It's not about the vertical scalers, which is a quite new feature that will actually size dynamically every individual pod according to current stress and resource consumption. Okay, it's a different thing. And it's not about the node scalers. Node scalers are mostly cloud vendor dependent. So every Amazon engine or Google will provide you with an API to scale the nodes. This talk is about the Kubernetes scheduler. Okay, so as you probably know, this component is in charge of watching the newly created pods and then deciding in which node this pod is going to live. Okay, it's going to be created. So the scheduler is, well, it's not a controller, but it's a controller in the sense that it watches the API, looks at the desired state, desired final states, looks at the current states, and moves things towards the desired state. Okay. Yeah, I actually stole this from Joe's Bedard's blog. But I really like this diagram, because it's very important to know exactly at which point the scheduler is going to interact with your API. Okay? So first, you write the pod definition into etcd. Okay? Then the scheduler retrieves the list of pods that are pending, but the scheduler is not going to act upon the pod directly. It's going to write a decision back to etcd. Okay? And it's etcd, the API and the kubelet, the other components that are going to actually create and run the pod. Okay? So it's important to note that this happens after authorization by the API, the admission controllers, and persistence in etcd. Okay? We will talk at the end why this is important. But happens before the kubelet actually pulls the image and runs the image. Okay. So yeah, this is just going a little deeper. You get the list of pods that are published, you apply your scheduling filter, create a binding, you write back the binding in the API server, and then this pod is updated with a new node name. Okay? Yeah, you need to watch for pods that are impending, have no node name assigned, and are explicitly requesting your scheduler. Okay, we will go into that later. So, yeah, I wanted to talk a little bit about the default scheduler, because it's a good starting point, okay? So if you know what the default scheduler is doing, you will get a lot of ideas for your own scheduler. So basically, it has two phases. One is filtering, and the other is ranking. Filtering is, we can call it like the hard phase and the soft requirements phase. So filtering is based on the pod resource request. So if this node cannot accept this pod, it's out of the list. Filtering depends on the data volumes that you need locally, or nodes that are explicitly discarded by selectors. Okay? Once you have the hard requirements out, you will rank the nodes depending on of course, the least requested priority, basically the node that has more free resources. Okay? The affinities and anti-affinities, I'm going to talk about that a little bit later. And I like the last one, the calculate spread priority. I didn't know about this one. It tries to separate the pods that belong to the same service. Okay? So by default, it's going to do a nice balance and spreading over all your nodes. Okay. Those are the hard constraints that you can use with the default scheduler. You are probably very familiar with them. I mean, you can have taints, you can have taints tolerance, you can have a node selector that explicitly matches a set of labels, etc. I'm not going to talk much about this because it's common stuff. Soft constraints are maybe a little more advanced. So you have, for example, the prefer no schedule effect, which is soft version of no schedule. For example, in your master nodes, you may prefer if you don't put too much effort in the master nodes, but if there is an emergency and the other nodes are not responding, you can use prefer no schedule, okay, for example. Node affinity is the same thing, but for the node selector, and the pod affinity. So pod affinity, have you used pod affinity before? And pods anti-affinity and these kind of things? Okay, so you can do explicit optimization. For example, if you have two components that talk a lot, okay, interchange a lot of bandwidth, so you want them together because it's more efficient, or the other way around, you have a pod that has a lot of privilege and a pod that has a lot of sensitive data, so you prefer if those two are not together, okay? Because you know, a user gaining privilege into one of the containers will be able to access the other. And you also have, this is an alpha feature, you have weights for the pods. Okay, one thing. It's very cool to think about relations between your pods and start to imagine that you want these two pods together, but you know, this is a relation graph, and this is not linear, okay? So don't become very happy with these kind of things, because then the scheduler will be more complex and will take more time, okay? So keep things to the minimum, if possible. So yeah, this pod priority is an alpha feature in 1.10, and you can establish a weight for the pods, and it will have three different effects. Preemption, so a pod that wants to be scheduled will kick out less important pods if if there is no room for everyone. Okay. The scheduling queue will have different priorities, so the most important pods will get scheduled first. And also out-of-resource eviction, which is like the first point, but the opposite situation. All the pods are in the node, so they will start evicting the less important ones. Okay. And yeah, then you have this taint-based eviction, which is also another alpha feature, okay, where you can express problems that you are having in the node as taints and tolerance. So, for example, if you don't have network connection, you can dynamically tag this node with a taint, and you can have also these toleration seconds, which means that the pod is going to be evicted, but it will wait, for example, 5 minutes. So if the network problem goes away in 2 minutes, it will stay in the node. This can be very useful if, for example, you have a lot of local state and it's heavy for you to destroy and recreate. Okay? So you want to leave that node, but not so fast. Okay? Not immediately. Okay. So that's basically what you can do with the default Kubernetes scheduler. Let's go and create our own Kubernetes custom scheduler. Why? The first question is why would you want to do that, right? Okay, so if you use the default scheduler, you are mostly limited to a set of hardware constraints like CPU, disk pressure, memory. There are 4 or 5 things. Or you need to come up with a manual and explicit set of labels and, affinities, anti-affinities, selectors, node selectors, which is basically a manual and a static thing, okay? What if you want to schedule based on different metrics, like application metrics? For example, you want, for HTTP latency or HTTP bandwidth, you want to schedule pods closer to the consumer. Or GPU performance. This is very hot now, for artificial intelligence, crypto coins, or artificial intelligence, graphics, all these kind of things. So you want to know exactly how many flops are available at this time. So this is a variable metric. It's like CPU, but for the graphical unit. Okay, you can do it with a custom scheduler. Or you are having a bottleneck. So most of the nodes, the service in general is behaving well, but one of the nodes is having problems and needs more workers there. Okay, to carry away all the work. Okay, so you can send more workers to that particular node. Just 3 examples. I'm sure you can come up with more. Okay. So from Kubernetes 1.6, you have multiple schedulers at the same time. So you don't have to go and replace the default one. You just have additional schedulers in the same cluster. Okay, this is very important. You will see why. This custom scheduler can run outside. You can directly contact the API and run it outside the cluster or run it inside as a pod. What I would recommend is you will run outside the cluster for testing, developing when you don't want to, recreate the pod and deploy and do all these kind of things. But eventually, when you have a proper version, it's much better if you run it inside because it's auto-contained, it's a pod inside the cluster. It's not external software that you have to contact. Okay. And obviously, once you create your own scheduler, it's, sky's the limit. Any API, any parameter you want to use for a scheduler, it's good. Yeah. A couple of considerations at this point. You will need to create a service account for this pod, but you already have a cluster role that is the kube scheduler. Okay? So this pod is going to contact the API and is going to modify and send objects and write objects to the Kubernetes API. So it needs this set of priorities. Okay? Not important for this talk, but just in case you actually want to do it. And also there are two types of bindings. There is the binding object, which was the default, but is deprecated in 1.7, and now you are supposed to use the binding sub-resource of the pod. Okay. Remember that the scheduler doesn't actually do anything. It just posts a decision, which is basically a binding object. It doesn't take the action itself. Yeah, and this command line is basically showing that with this RBAC role, you have both. You have access to the bindings and the pod bindings. Okay. Okay. So let's go to the code. Suspense. Yeah, there we go. Okay. So basically, I have a vanilla, pretty simple Nginx. And the only thing I need to do is to claim that I need that scheduler in particular for this set of pods. Okay? That's all you need to do on the pod definition. On the implementation, you need to do a little more. Okay? So the implementation, basically what you do is you subscribe to this event queue. You subscribe to the new API pods. And you check that this pod is one of the is interesting to you. Okay, so it's pending. The scheduler name is the one that you are looking for, and it was just added. Okay. And then you have the decision algorithm. Obviously, we have implemented this using Sysdig metrics. Okay, but you can go and replace this method with any other API that you want. And that's basically the main loop. So let's go and try it out. Okay, so these pods are going to be pending forever. Okay, they are requesting a scheduler that doesn't exist. So they are never going to leave the pending state. Basically, I'm running my scheduler. I will post the GitHub address at the end. Okay? This is my scheduler. Obviously, I need a kubeconfig for the certificates and so on. I specify one of the metrics. You can put plus or minus, depending if you want to order for, if more is better or less is better, okay, in terms of ranking. And then this is the Sysdig token for the API. Okay. So it has detected that these nodes are pending, contacted the API, and according to this net HTTP request time, scheduled all the nodes. Okay? So hopefully, okay. Simple as that. Okay, now if we go back here. Okay. That's what I told you to, first look at the default scheduler. Because creating your, this example was very simple, but creating your scheduler is a brave thing to do, okay? I will show you some improvements that I have coded for this one, but there is a lot of things that can grow wrong, okay? First improvement, this one is implemented. I will go back to the terminal. Metrics cache is a very common case that you have a new deployment and suddenly you have 20 new pods. Do you really need to query the API 20 times? Probably not. Okay. So the first obvious optimization that you can do is create a metrics cache. Every time that you retrieve a metric from the API, you put a timestamp and you decide if it's fresh or not. If you want to go even further, you can do adaptive cache. So you know metrics that are changing more often, you retrieve more often from the API. Lots of things you can do, okay, there. This is very important. This is very important, the failsafe mechanism. You need a lot of different, you need to take into consideration everything that can go wrong. For example, the metrics API is not responsive. It happens twice a month, okay? It happens twice a month. Metrics API is just not responding. Okay, the cache can mitigate this, but for a few seconds. Eventually, you have to give up, okay? You are too strict with your restriction, and there is no good candidate. Maybe you need to relax your requisites. Timeout. Okay, don't forget that we are writing a scheduler, and the scheduler is an optimization mechanism. If it's taking too long, it's not worth it anymore. Okay, so it's better to time out and go back to the default one. Okay. And multiple exception, code has bugs. Okay. So you need to catch any exception that may happen in your code. Okay. You always need a plan B. That's the main idea. I mean, if your scheduler fails, pods are pending forever. That's not good. I mean, any decision is better than no decision at all. So one of the most obvious strategies in this case is to delegate to the default scheduler. There is a small problem here, and that goes back to the first diagram. And the small problem is that you cannot actually change the scheduler on a running pod. It's not a permissions thing, it's forbidden by design. Okay? So what you need to do is you need to actually go back to the parent, let's say the deployment, change the parameter in the deployment. The deployment will observe that the desired state is not compliant. It will kill the pods, and it will recreate new ones. Okay. Another thing that you can do is that you can do requeuing. So if your main method returns a certain code error, the API will understand that it needs to put the pods back into the pending queue. Okay? You can do that. I never tried myself, but you can do that. So yeah, in this case, just okay, another fast, simple, stupid demo. Okay, we have the pending pods, and now I want to schedule, but my token is, I made a typo in my token, so the API is not going to respond, so I'm alone. Okay. Okay, I have the fallback that will delegate to the default scheduler in this case. It's all this part of the code. Okay. Basically, what it does is it asks for the parent object. The parent object is a replica set. Ask for the parent object of the parent object, which is a deployment. Retrieves the deployment, modifies this parameter, and then the deployment will actually, if you realize the names of the pods, okay, those are new ones. It's before what I said. I mean, it's the thing that I said before. There is no way of changing a running container. Okay, and another improvement number 4 or number 5, I don't know, is, everything I was explaining at the beginning of the talk about all these kind of cool things that you can do with the default scheduler, they are not implemented in your scheduler by free. Okay, you need to actually go and code them. Okay. So another obvious improvement is adding more variables to the mix, like respecting the CPU limits, honoring the affinities and anti-affinities, all these kind of things, which is probably quite hard to implement all this stack of priorities and relations. Yeah, another thing that you can do is writing a mutation admission webhook, okay? In case you, for example, you have 300 YAMLs with 300 definitions of deployments and pods, and you don't want to go into every one of them and change the scheduler, you can always create an admission controller. This also goes back to the first diagram, because the admissions controllers happen before the object is persisted in etcd. So at this point, you can actually go and change the scheduler name. Okay. At this point, it is possible. Later on, it is not. Yeah, and then if for some reason you want to have, one of the pods that is pending can be selected by more than one scheduler. I don't know why, maybe for high availability reasons. Then, you have to be careful with who gets the log object, who changes the state of the pod, leader election. But, that was an entire subject at college, so I'm not going into that at this moment. Okay. So, yeah, that's basically what I wanted to show. If you have any more questions at this point, yeah?
So instead of writing a new scheduler from scratch, can you borrow features of the default one?
Yes, the default one is, you have the source available. So, yeah, he was asking that instead of writing your own scheduler, if you can go and write a... Yeah, like taking the default one and...
Like to use the affinity and so on, but also extend on these features with your own
Yeah, then
logic.
you will, I assume you will get the code of the default Kubernetes scheduler, okay. And you will commit on that. You will complete over that. That's a good, if you want to do... Thing is that if you are doing a scheduler, you probably want a very specific task, very, very specific task, so you don't care that much about all the anti-affinities and these kind of things. But if you want to do a more complete one, probably you are better off starting with the default scheduler.
Can you actually evict some another pods based on your scheduler, or just schedule a new one?
No, you cannot evict. Scheduler, once you have the decision and you have taken the decision and written the decision to the API, scheduler work is done.
Hi.
Hello.
Just one question here. If you happen to have your custom scheduler as simple as you wrote it there, and it tries to put a pod in a node that has no memory left or not enough resources, what happens then? Does Kubernetes does anything about that, or it doesn't care and you just get an error basically?
Okay, so you put this. Okay, so you are not taking into consideration the limits, and you put the no. I think at that point, the kubelet will start misbehaving. I have not tried that, but it's like any other process that goes over the hardware limits in your operating system.
So it will not try to perform any sort of checks or anything like that?
If you don't code the performance, that's what I was saying, that if you can use the default one, use the default one, because otherwise you will have to code a lot of things, a lot of restriction.
One more.
Okay, one more.
So you mentioned when your scheduler is failing, you can edit the deployment and change the scheduler. You can't edit a stateful set. So you're saying you can only use this for deployments now?
No, I was using deployments. What I say is that you cannot go and change the pod directly. You need to contact the entity that created the pod.
Yes, but stateful sets, you can't edit them unless it's a replica and something else. So I'm just asking if there's a way of doing it without editing the resource.
I don't think so. I mean, I don't know if... I suppose you need to go to the stateful set and change the parameter again.
Okay, thank you.
Okay, thank you.
Hey, just a quick one. If you use the mutating admission hook and you go to your custom scheduler, but it fails, and you want to use the default scheduler, wouldn't the hook rehook it back to your custom scheduler?
Okay, good question. You change it, so you change the mutation, and then no, because you are directly writing the object that is in etcd, you know, and that happens after, if I'm correct. But you do authorization, you do the mutation webhook, it gets modified, it gets written to the etcd, and you retrieve the object from etcd and write into etcd again. So if I'm not wrong, it won't happen. It will still work, this mechanism.
Anyone else?
What?
Oh, will you post
yes.
your presentation?
Yes, I will put my presentation. Actually,
you should have put your Twitter handle. Oh, there it is, right there.
It's my Twitter
he'll tweet it
handle, and yeah. So, you know, open source, PRs welcome, all that kind of stuff. So this implementation is naive, but it's not so naive. I mean, it has cache, and it has a fallback mechanism. It's starting to do some more interesting things, but still needs more improvement because I can consider it, you know, something that you will put in production.